Here we want to be able to graph the function and then give the domain and range. We have f of x, which is equal to the greatest integer function of -3/4 x. Okay, so what we want to do is we want to graph this function. Okay, so we want to make a table. So we have a table which is x, and then what we want to do is find f of x, okay, which is equal to the greatest integer function of -3/4 x. Okay, and then remember that what we're getting is an ordered pair of x and then f of x, and again x is going to represent our y. Okay, now our goal, and what our goal is to then find out values of x that we can plug into this greatest integer function, and then determine what our integer is. So our goal in the range, because remember this is the range, okay, and the range should always represent the set of integers, so y, such that y is an integer. Okay, now another way of showing that is that you have the set of integers that go from -3, -2, -1, 0, 1, 2, and then 3, right? So then what that means here is that these are the types of numbers that we're going to get as the output. The input is now what we need to plug in to determine what our output's going to be. So the first thing we want to do is, okay, let's plug in a value for x that's going to give us an integer. In order to do that, we need to pick a number that's going to give us that integer. So we want to take the reciprocal of 3/4. So the reciprocal of 3/4 in this case is going to be +4 thirds. Okay, so if we want to find this function, that means we're going to plug x to be 4 thirds. So we have the greatest integer function of -3/4 times 4 thirds. Okay, so that means we're going to end up getting what? We get -12/12, which actually equals what? 1, right? So just to save some space, we're going to go ahead and then put in the value of -1. Okay, so this is going to give us -1. Okay, now remember that the definition of the greatest integer function of -1 is the following. Okay, that means that we have -1 as our x. So what number is less than or equal to -1? Well, the answer is -1. So therefore, this answer is -1. So at 4 thirds, we have a y value that represents -1. Okay, now next, let's pick another fraction that's going to give us a numerator that can be divisible by 4. So we already got 4 thirds. Now let's take a look at 8 thirds. Okay, so we're going to plug that in. So we have -3/4. We're going to multiply that by 8 thirds. Okay, so when we multiply that together, that's going to give us -2. So therefore, what is the greatest integer of -2? So if -2 is x, what number is either less than or equal to -2? Well, the answer is -2. So therefore, we have 8 thirds, -2. Okay, now let's take a look at 0. Okay, so if we plug in 0 for the input, that means we take -3/4, multiply that by 0, and then we get 0 as our number. Now, again, we want to figure out, okay, well, if we have 0, we know that it's an integer. So remember that if we have 0, the number that's either less than or equal to 0 is 0. So that gives us 0. So therefore we have another ordered pair of 0 and 0. Okay, now let's take the negative version of the value of 4/3. So if we take negative 4/3, and now let's plug it into this function. So we have negative 3/4 times negative 4/3. Well, that gives us positive 1. And again, that's going to equal 1 because the greatest integer of positive 1, which is 1. So therefore, we have negative 4/3, and then that's 1. Okay, then the last one, we're going to go negative 8/3. So therefore, that's going to give us negative 3/4 times negative 8/3. And that gives us positive 2. So again, what do you think that's going to look like? Well, again, we can see that the greatest integer less than or equal to 2 is going to be 2. And so therefore we have negative 8/3 and then 2. Okay, so now the goal here is that now we want to do is we want to be able to then use our inputs to be on our x-axis. So we know we have 0. We know that this represents positive 4/3. And we know that this represents positive 8/3. And then over here to the left, this is negative 4/3. And this is negative 8/3. Okay? And so what else do we know? We know that this is negative 1. We know that this is negative 2. And this is negative 3. And this is positive 1, positive 2, and then positive 3. Okay, now what we're going to do is now we're going to plot these points to then determine what our graph is going to look like. Okay, so at positive 4/3, okay, we know that we have negative 1. Okay, now if you notice at positive 4/3, we get a negative 1 as an output. Okay, and what that means is if we take another number, okay, 0, if you look at 0, that's going to be at 0. So that means that when we go all the way over to the x value of 0, we have an open circle there. Because at 0, we're going to have a closed circle, and then it's going to go all the way to negative 4/3. Because if you look at negative 4/3, okay, that's going to have an output of 1. So that means up here, it's going to have an output of 1, and then that's going to go all the way to negative 8/3, which has an open circle. Because negative 8/3 has a positive 2 as an output. So therefore, this is the step function. That's what that's going to look like, okay? And then over here at positive 8/3, you can see that it has an output of negative 2. So that means that down here you're going to have a closed circle, and then over here to your left you have an open circle. Now you can see here how the closed circle and then is going to the left. That's because the inside function is negative. Now if this was positive, you can see that it would go the opposite direction. But now let's see if we can find this graph on our solution. Okay, so it looks like we can eliminate A and C because they're open circles going to the left, or this says you have a closed circle going to the right. So that means that this would, so you're eliminating A and then D. Now we need to look at B and then look at D. Now if you look at B, you will notice that the incremental level in between here and here is a little over 1. Okay, and that's not what we did. We used the fraction, okay, negative 4/3. So let's take a look at this one here. Okay, so this one, if you look at D, okay, this is in between the 1. So we have to decide whether it's going to be D or B. So we click B because of the following, and let me show you. I want to show you the difference between these two. Okay, so we're going to compare these on that graph. Okay, so these are some of the details that you want to pay attention to when you're looking at the graph. Okay, so if you look down here, okay, this is going from 0, and that's -1, and then this is around a -1.3. Over here, this is 0, and there's -1. Well, if you look at our incremental here, right, this is -4/3. So what does -4/3 actually equal? Okay, well, let's find out, right? -4/3 is what? It's -1.33. And that's positive 1.33. So this goes over that -1, okay? Whereas in this incremental, this is smaller. So therefore, that's why you're choosing B, okay? Now, let's take a look at the second part. It says, find the domain of this function. Okay, well, what is the domain of this function? Well, the domain of the function means, like, what are all the x values that we can substitute into this function, right? So this is the domain. Well, if you notice, we can pick any values that go from positive infinity to negative infinity. So that's going to represent the domain of this function. So let's go ahead and put that in there. So we have parentheses negative infinity, comma infinity with a parenthesis, and then check our answer, and there's our result. Now, what is the range? Well, let's go back and look at the range. The range has to only include the integers because those are the only values that we should have when we're looking for the integers, right? So therefore, the integers are this set of integers. So when we select our result, it's going to be D because that represents all the integers. So let's check our answer, and then there's our result.